For billions of years, Earth has been doing something so ordinary that we rarely stop to think about it. It spins. Every second of every day, our planet rotates around an invisible axis running from the North Pole to the South Pole. We don't feel it. We don't hear it. We don't see it happening. But Earth's rotation controls some of the most fundamental patterns of life on our planet. It helps create day and night. It influences winds and ocean currents. It affects weather systems. And it contributes to the conditions that make Earth such a remarkable place for life. But imagine something impossible.
Imagine that. For just 5 seconds, Earth suddenly stopped rotating. Not gradually, not over millions of years, but almost instantly. The planet stops. Then, 5 seconds later, it starts rotating again. Would anything happen? Would people notice? Would oceans rise? Would buildings collapse? Or would those 5 seconds pass almost unnoticed? The answer is one of the most fascinating thought experiments in planetary science. And the first thing we need to understand is that Earth is not standing still right now.
At the equator, Earth's surface is rotating at roughly 1,670 kilometers per hour, or about 1,040 miles per hour. You are already moving at incredible speed. You just don't feel it because everything around you is moving together. The ground beneath your feet, the atmosphere above you, the oceans, the buildings, the trees, the cars, and even your body. Everything is participating in Earth's rotation.
Now imagine Earth suddenly stops. The ground stops. But everything that was moving with the planet would still have momentum. And that is where the real danger begins. Physics gives us a simple rule. An object in motion tends to remain in motion unless another force changes its movement. So if Earth's surface suddenly stopped rotating, the atmosphere would not necessarily stop at exactly the same moment. The oceans would still have momentum, and everything that was not firmly attached to the ground would continue moving eastward. At the equator, that motion could be more than 1,000 miles per hour. Imagine standing outside when the ground beneath you suddenly stopped moving. You would not simply remain standing there. You, along with the air around you, would still be moving at Earth's previous rotational speed.
The result would be catastrophic. But there is an important detail. Earth would not actually be able to stop instantly through any known natural process. The amount of energy and torque required would be unimaginably enormous. So this scenario is purely hypothetical. Scientists use thought experiments like this because they help us understand how physics works. And if we temporarily ignore the impossible mechanism that stops Earth, we can explore what the consequences would look like. The first major effect would be the atmosphere. The atmosphere rotates along with Earth because Earth's gravity and friction keep it moving with the planet. If the solid Earth suddenly stopped while the atmosphere continued moving, enormous winds would develop. Near the equator, these winds could theoretically approach the previous rotational speed of Earth's surface. That means winds potentially exceeding 1,000 miles per hour. For comparison, some of the strongest hurricanes ever measured have produced sustained winds of around 200 miles per hour.
Now imagine winds several times stronger. These would not behave like an ordinary hurricane. They would be a planet-wide atmospheric catastrophe. Buildings would be destroyed. Forests would be flattened. Infrastructure would be devastated. Dust, debris, and enormous amounts of material could be carried through the atmosphere. But the atmosphere would not be the only problem. The oceans would also continue moving. Water has mass, and water has momentum. If the planet stopped rotating suddenly, enormous quantities of ocean water would continue moving across the surface. Coastal regions could experience devastating flooding.
The Earth would not have time to completely reorganize its atmosphere and oceans in only 5 seconds. But the initial effects could still be extraordinarily destructive because the starting velocities are so enormous. The consequences would depend on exactly what Earth stops rotating means. If the solid planet suddenly stopped, but the atmosphere and oceans continued moving, the surface environment would experience extreme forces. If somehow the entire Earth, including the atmosphere and oceans, were magically stopped together, the situation would be very different. There would be no enormous relative motion between the ground and atmosphere. But the physical mechanism required to stop every part of Earth simultaneously would violate the assumptions of the thought experiment. In other words, there is no realistic way for the entire planet to simply press a pause button. Still, let's imagine that somehow everything stops together.
For 5 seconds, there would be no rotation. The sun would still appear to move across the sky because Earth would still be orbiting the sun. But the normal progression of the sky would briefly change. Then, after 5 seconds, Earth would begin rotating again. And once again, the problem would be momentum. Restarting Earth's rotation instantly would create enormous forces. Anything not moving exactly with the Earth's surface would be thrown into motion relative to the ground. The atmosphere and oceans would once again be subjected to tremendous acceleration. The Earth's crust would also experience extraordinary mechanical stresses. Earthquakes could potentially occur. Tectonic systems could be disturbed. But the exact consequences are impossible to calculate without specifying how the stopping and restarting mechanism works. And this is an important lesson. The phrase, "Earth stops rotating for 5 seconds," sounds simple, but scientifically, it hides a huge number of questions. Does the atmosphere stop? Do the oceans stop? Does Earth's core stop? Does the moon's gravitational influence change? Does the planet restart instantly? How does the energy disappear? Where does that energy go? These details completely change the outcome. There is another fascinating consequence. Earth's rotation slightly affects the shape of our planet. Earth is not a perfect sphere. It is slightly wider around the equator than from pole to pole. This is partly because rotation creates a small outward effect. If Earth stopped rotating permanently, over extremely long periods, the planet's shape would gradually adjust. But 5 seconds would be far too short for Earth to physically reshape itself in any major way.
So the biggest immediate danger would not be Earth's shape. It would be momentum. The world around us is already moving at extraordinary speeds. We simply don't notice because we are moving together. That is one of the strangest facts about life on Earth. You may be sitting completely still right now, but if you are near the equator, you are traveling around Earth's axis at more than 1,000 miles per hour. And at the same time, Earth is orbiting the sun at roughly 107,000 kilometers per hour. The solar system itself is moving through the Milky Way. So even when you feel motionless, you are actually part of several enormous cosmic motions happening simultaneously. That is why stopping Earth's rotation would be so dramatic. The danger would not come from the planet suddenly losing gravity. Gravity would still exist. It would come from the fact that everything on Earth is already moving. 5 seconds may sound insignificant, but when an entire planet is rotating at hundreds or thousands of kilometers per hour, even a few seconds could matter enormously if that rotation were changed suddenly. You are actually part of several enormous cosmic motions happening simultaneously. That is why stopping Earth's rotation would be so dramatic. The danger would not come from the planet suddenly losing gravity. Gravity would still exist. It would come from the fact that everything on Earth is already moving. 5 seconds may sound insignificant, but when an entire planet is rotating at hundreds or thousands of kilometers per hour, even a few seconds could matter enormously if that rotation were changed suddenly. Fortunately, there is no known natural process capable of suddenly stopping Earth's rotation for 5 seconds. Earth's rotation does change naturally, but extremely slowly. The moon's gravitational interaction with Earth gradually slows our planet's rotation over immense periods of time. The change is tiny, so tiny that humans would never notice it from day to day. Earth will continue spinning. The sun will continue rising and setting. The atmosphere will continue moving with the planet. And the oceans will continue following the rhythms of a world that has been rotating for billions of years. The thought experiment teaches us something much bigger than what would happen during 5 seconds of darkness or chaos. It reveals how much of our everyday existence depends on motion. We live on a moving planet. We travel through space without feeling it. And the stability we experience every day exists because enormous physical systems remain in balance. Earth doesn't need to stop for 5 seconds to remind us how powerful motion can be. All we have to do is look at the world around us and realize that beneath our feet, an entire planet is spinning through space. And if that motion ever stopped suddenly, even for just 5 seconds, the consequences could be far more violent than anything humanity has ever experienced. And perhaps the most fascinating part is what would happen after those 5 seconds. If Earth suddenly began rotating again, the danger would not simply disappear. Everything around the planet would once again need to accelerate to Earth's enormous rotational speed. The atmosphere, oceans, and surface would experience tremendous forces as motion returned. For humans, this would be a reminder that Earth's rotation is not just an astronomical fact. It is part of the delicate system that makes our everyday environment possible. We rarely notice Earth spinning beneath us, but if that invisible motion suddenly changed, even for a few seconds, the world we know could be transformed in an instant. Earth's rotation may feel invisible, but it controls our world. If it suddenly stopped, even briefly,
One of Jupiter's most iconic features is the Great Red Spot, a gigantic storm that has been raging for over 350 years. First observed in the 17th century, this storm is so massive that Earth could fit inside it. With wind speeds exceeding 400 miles per hour, the Great Red Spot is the largest and longest-lasting storm in the solar system. Although the storm has been gradually shrinking in recent decades, it continues to captivate scientists and space enthusiasts alike. Its reddish color is thought to be caused by complex chemical reactions involving sunlight and atmospheric compounds, though Jupiter is not alone in space. It is surrounded by an incredible family of more than 90 known moons, effectively forming a mini solar system. Among these, the 4 largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, discovered by Galileo Galilei in 1610. Io is the most volcanically active body in the solar system, with hundreds of erupting volcanoes. Europa is of particular interest to scientists because it is believed to harbor a subsurface ocean, making it one of the most promising places to search for extraterrestrial life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and it possesses its own magnetic field. Callisto is heavily cratered and may also contain an underground ocean. These moons provide valuable insights into planetary formation and the potential for life. What if there were a planet so massive that it could swallow every other planet in our solar system and still have room to spare? A world with storms larger than Earth, a magnetic field powerful enough to trap deadly radiation, and dozens of mysterious moons. Welcome to Jupiter, the undisputed king of our solar system. Unlike Earth, Jupiter is a gas giant, meaning it doesn't have a solid surface. Instead, it is primarily composed of hydrogen and helium, similar to the Sun. As you move deeper into the planet, the pressure becomes so intense that hydrogen transforms into a strange state known as metallic hydrogen, capable of conducting electricity. At its core, scientists believe there may be a dense, rocky or icy center, although this is still a topic of ongoing research. The extreme conditions within Jupiter make it impossible for any spacecraft or human to land on it. Any attempt to descend into its atmosphere would result in being crushed by immense pressure and vaporized. Jupiter possesses the strongest magnetic field of any planet in our solar system, about 20,000 times more powerful than Earth's. This magnetic field creates an enormous region of charged particles known as the magnetosphere, which extends millions of miles into space. This powerful environment generates spectacular auroras near Jupiter's poles, far more intense than those seen on Earth. However, the radiation trapped within this magnetosphere is extremely dangerous, posing significant challenges for spacecraft. NASA's Juno mission, launched in 2011, was specifically designed to withstand this harsh environment while studying Jupiter's interior and magnetic. Jupiter is the largest planet in our solar system, a true giant that dominates the space around it. Located about 484 million miles, or 778 million kilometers from the Sun, this gas giant has fascinated astronomers for centuries. Named after the king of the Roman gods, Jupiter lives up to its name with its immense size, powerful gravity, and majestic presence. If Jupiter were hollow, more than 1,300 Earths could fit inside it. Despite its enormous size, Jupiter spins incredibly fast, completing one full rotation in just about 10 hours, making it the fastest spinning planet in the solar system. This rapid rotation gives Jupiter its distinctive striped appearance, formed by bands of clouds moving in opposite directions. While Saturn is famous for its stunning rings, Jupiter also has a faint ring system. Discovered in 1979 by NASA's Voyager 1 spacecraft, these rings are composed mainly of tiny dust particles created by impacts on Jupiter's small inner moons. Though not as visually spectacular as Saturn's rings, they add another layer of complexity. Jupiter is more than just a planet. It is a symbol of the immense power and mystery of our universe. From its colossal storms and powerful magnetic field to its fascinating moons and protective role, Jupiter continues to inspire scientists and dreamers alike. As we explore this giant world, we are reminded of how small our own planet is in comparison, and yet how fortunate we are to exist in a solar system shaped and safeguarded by this celestial king. The more we learn about Jupiter, the more we understand not only the universe around us, but also our place. So the next time you look up at the night sky, remember that beyond the twinkling stars lies Jupiter, the mighty guardian of our solar system, silently shaping the destiny of worlds. Jupiter's immense gravity plays a crucial role in protecting the inner planets, including Earth. Acting as a cosmic shield, Jupiter attracts and deflects comets and asteroids that might otherwise collide with our planet. A dramatic example of this occurred in 1994 when comet Shoemaker-Levy 9 collided with Jupiter, providing scientists with a rare opportunity to observe such an event and highlighting Jupiter's protective. A day on Jupiter lasts only 10 hours, but a year takes nearly 12 Earth years. Jupiter's gravity is 2.5 times stronger than Earth's. The planet emits more heat than it receives from the Sun. Jupiter's magnetosphere is the largest structure in the solar system. Ganymede, one of Jupiter's moons, is the largest. A common question is whether Jupiter could ever become a star. While it contains many of the same elements as the Sun, Jupiter would need to be at least 80 times more massive to initiate nuclear fusion in its core. Therefore, despite its grandeur, Jupiter will remain a planet, a magnificent one, but not a star. Jupiter has been the target of several groundbreaking space missions. The Pioneer and Voyager missions provided the first close-up images, while the Galileo spacecraft orbited Jupiter from 1995 to 2003, delivering invaluable data about the planet and its moons. Currently, NASA's Juno spacecraft continues to revolutionize our understanding of Jupiter. By studying the planet's gravity, magnetic field, and atmospheric composition, Juno has revealed that Jupiter's core may be fuzzy rather than solid, and that its atmospheric storms extend deep beneath the cloud tops. Looking ahead, future missions such as NASA's Europa Clipper and the European Space Agency's JUICE mission aim to explore Jupiter's icy moons in greater detail, particularly in the search for signs of life. If you enjoyed this incredible journey through our solar system, don't forget to like this video and subscribe to Cosmic Secrets for more fascinating space stories. Here, we explore the mysteries of the universe, from distant planets and powerful black holes to the search for life beyond Earth. Share this video with fellow space enthusiasts and become part of our growing cosmic community. The universe is filled with endless wonders and hidden secrets, and this is just the beginning of our journey together. Stay curious, keep looking up, and join Cosmic Secrets as we continue to uncover. Right now, as you're watching this video, engineers, scientists, and billionaires are spending billions of dollars trying to get humans to one single destination. Not the moon, not some distant galaxy. Mars. But here's what they don't tell you in school. Mars isn't just a red rock floating in space. It's a world with ancient volcanoes, frozen oceans, deadly dust storms, and possibly the next home for the human race. Stay with me, because by the end of this video, you'll look at the night sky completely differently. Section 1. What is Mars? Mars is the fourth planet from the Sun, sitting about 142 million miles away from it. It's named after the Roman god of war, and honestly, that name fits. Mars is violent, extreme, and unforgiving. It's roughly half the size of Earth, but don't let that fool you. The total land area on Mars is actually similar to Earth's landmass because Mars has no oceans covering it. Every inch of Mars is raw, exposed terrain. A Martian day, called a sol, is 24 hours and 37 minutes. So if you woke up on Mars, your morning routine would feel almost normal. But a Martian year? That's 687 Earth days. 2 full years would pass on Earth before Mars even completes one trip around the Sun. And the gravity on Mars is only 38% of Earth's gravity. That means if you weighed 180 pounds here, you'd weigh just 68 pounds on Mars. You could literally jump 3 times higher than you can right now. Sounds fun until you realize the atmosphere is 95% carbon dioxide. One breath outside without a suit, and you'd be dead in minutes. Section 2. The extreme terrain. Mars is home to some of the most extreme geography in the entire solar system. Let's start with Olympus Mons, the largest volcano ever discovered. It stands 16 miles high. That's nearly 3 times the height of Mount Everest. It's so wide that if you stood at its base, the peak would be beyond your horizon. You wouldn't even know you were standing on a volcano. Then there's Valles Marineris, a canyon system that stretches over 2,500 miles long and drops 5 miles deep. The Grand Canyon could fit inside Valles Marineris like a small ditch. This isn't just one of the biggest geological features on Mars, it's one of the largest in the entire known solar system. Mars also has polar ice caps, just like Earth, but instead of only water ice, the Martian poles contain dry ice, frozen carbon dioxide. In winter, these caps grow massive. In summer, they shrink as the carbon dioxide evaporates back into the thin atmosphere. And then there are the dust storms. Mars is famous for them. These aren't gentle breezes. Global dust storms on Mars can engulf the entire planet for months at a time, blocking sunlight and dropping temperatures even further. NASA's Opportunity rover, which was designed to last 90 days, actually survived for 15 years until one of these massive dust storms. Section 3. Water, the biggest mystery. Here's where things get truly mind-bending. Scientists have found overwhelming evidence that Mars once had liquid water, rivers, lakes, and possibly even a shallow ocean covering its northern hemisphere billions of years ago. We're talking about a planet that may have once looked a lot like Earth. Ancient riverbeds and lake basins have been photographed by Mars orbiters. Minerals that only form in the presence of liquid water have been discovered on the surface. And beneath the south polar ice cap, radar data strongly suggests there's a liquid saltwater lake buried miles underground, even today. That's not nothing. That is potentially everything. Because where there is water, there is the possibility of life. No one is saying little green men, but microbial life, bacteria, extremophiles, organisms that survive in the harshest conditions may have existed on Mars in its ancient past, and some scientists believe they might still exist underground, shielded from radiation, clinging to whatever warmth and moisture is left. We haven't confirmed it yet, but we haven't ruled it out either. Section 4. The Race to Mars. Humans have been fascinated with Mars for centuries, but in the last decade, that fascination has turned into a full-blown global race. NASA's Perseverance rover, which landed in February 2021, is currently exploring Jezero Crater, an ancient lakebed. It's drilling into rocks, collecting samples, and looking for signs of ancient microbial life. It has already made history by producing oxygen from the Martian atmosphere, a breakthrough for future human missions. China landed its own rover, Zhurong, on Mars in 2021, making it only the second country to successfully operate a rover on the Martian surface. And then there's Elon Musk and SpaceX, who have stated their goal clearly: make humans a multi-planetary species. SpaceX's Starship rocket is being built specifically for Mars. Musk has publicly said he wants to put humans on Mars within this decade, and he means it. The plan? Send cargo missions first, build infrastructure, establish fuel production using Martian resources, then send humans. It's not science fiction anymore. It is an active, funded engineering project happening right now. Let's be honest about something that most Mars hype videos completely skip over. Mars is trying to kill you in multiple ways, simultaneously. First, radiation. Earth has a magnetic field that shields us from deadly solar and cosmic radiation. Mars lost its magnetic field billions of years ago. That means the Martian surface is constantly bombarded by high-energy radiation from the sun in deep space. A single year on Mars would expose a human to radiation levels far beyond safe limits, dramatically increasing the risk of cancer, organ damage, and cellular breakdown. You can't just walk around on Mars. You'd need to live underground or inside heavily shielded habitats for most of your life. Second, the temperature. Mars is brutally cold. The average surface temperature is around -80 degrees Fahrenheit. At the poles in winter, it can plunge to -220 degrees. Even on a warm summer day near the equator, temperatures might briefly hit 70 degrees Fahrenheit, but then crash back below freezing after sunset. No insulation on Earth prepares you for that kind of daily temperature swing. Third, the pressure. The atmospheric pressure on Mars is less than 1% of Earth's. That's thinner than the air at the top of Mount Everest, and Everest can already kill an unprepared climber. On Mars, without a pressurized suit or habitat, your blood would literally begin to boil. Not from heat, but because the pressure is so low that liquids vaporize at body temperature. Fourth, perchlorate. The Martian soil contains toxic chemicals called perchlorates, salts that are harmful to human health and would contaminate any food grown in unprocessed Martian dirt. Before any farming could happen, the soil would need to be chemically treated and neutralized. This isn't meant to scare you away from Mars. It's meant to show you the scale of the engineering challenge we're actually facing. Every single one of these problems has a potential solution, but none of them are easy, and none of them are cheap. The people who go to Mars first will be some of the most courageous, disciplined, and prepared right now. If this video blew your mind, smash that like button and subscribe, because we're covering the... What if you had the power to go back in time, but only for 1 hour, and whatever you changed could destroy everything? It started on a cold night in Chicago. Ethan Cole wasn't a hero. He wasn't even someone people noticed. A quiet physicist, working late hours in a forgotten laboratory, chasing a theory most scientists called impossible: time travel. For years, Ethan believed time wasn't a straight line, but a loop, a fragile system that could be bent just slightly without breaking. And on that night, after countless failed attempts, he finally did it. The machine hummed softly. Blue light flickered across the room. His heart pounded as he stared at the digital timer on the screen. Temporal jump, 60 minutes. 1 hour into the past. Nothing more, nothing less. Ethan hesitated. This wasn't just science anymore. It was power. But then his phone buzzed. A news alert. Massive accident on I-90 highway. 12 dead. His eyes froze on the screen. He recognized the time. It hadn't happened yet. Without thinking, Ethan stepped into the machine. A blinding flash. Silence. Then, the hum of traffic. The world snapped back into place. He was standing outside the lab 1 hour earlier. Cars rushed by. People walked normally. The world, unaware of what was coming. Ethan checked his watch. 59 minutes. He ran. The highway wasn't far. As he reached the scene, everything looked normal. Too normal. No chaos, no sirens. Just life. But Ethan knew. Somewhere in the next hour, something would go horribly wrong. He scanned every car, every movement, every detail. Then he saw it. A black SUV. Driving slightly off, swerving. The driver looked distracted, or worse. Ethan's pulse raced. He had to stop it. He ran onto the road, waving his arms. Cars honked. The SUV slowed slightly, then swerved again. Something wasn't right. Ethan moved closer, trying to see inside, and that's when he noticed. The driver wasn't unconscious. He was staring straight ahead, unblinking, almost lifeless. A chill ran down Ethan's spine. This wasn't just an accident. Something else was happening. Suddenly, a loud crash echoed behind him. Another car lost control, smashing into the divider. Panic spread instantly. Ethan turned back, and in that moment, the black SUV sped up, straight into traffic. The explosion of metal and glass was deafening. Cars collided, flames erupted, people screamed. It happened exactly as the news had said. Ethan stood frozen. He'd failed. Even with time travel, he couldn't stop it. The world glitched, reality twisted, and in a flash, he was back in the lab. Ethan fell to his knees, breathing heavily. The machine beeped. Jump complete. But something was wrong. The news on his phone changed. Highway crash claims 18 lives. Ethan's heart dropped. He made it worse. That's when he realized the truth. Time wasn't meant to be changed. Every attempt had consequences. But Ethan wasn't ready to give up. He reset the machine. Again, and again, and again. Each jump, another attempt. Each attempt, another failure. Sometimes the crash happened earlier. Sometimes it happened differently, but it always happened. And every time, more people died. Ethan started noticing patterns, small details repeating, moments that felt familiar, like time was resisting him. Then one jump changed everything. Ethan arrived earlier than before. This time, he followed the SUV before it reached the highway. He needed to know why. The vehicle turned into a quiet street, slowed down, and stopped. Ethan approached cautiously, heart pounding. He looked inside and froze. The driver was him. Same face, same eyes, but older, tired, broken. Ethan stepped back, shaking. This isn't possible. The older version of him looked up slowly, as if he knew, as if he'd been waiting. "You finally figured it out," the older Ethan said. "What is this? What's happening?" The older Ethan sighed. "I tried to stop it too." "How many times?" Ethan asked. The older version looked away. "I lost count." Ethan's mind raced. This doesn't make sense. Why does the crash keep happening? The answer came quietly. Because we cause it. Silence. Every attempt to stop the accident created it. Ethan stepped back in horror. No, that's not possible." The older Ethan said, "You stepping into the road, the panic, the chain reaction, it all starts with you." The truth hit like a wave. He wasn't saving lives. He was the reason they were lost. Tears filled Ethan's eyes. "Then how do we stop it?" The older version looked at him with a sadness that felt endless. "You don't." Ethan shook his head. "There has to be a way." The older Ethan stepped out of the car, slowly, weakly. "I spent years trying to fix it. Every possibility, every outcome." "And?" Ethan whispered. "There's only one way." Ethan held his breath. The older version looked him straight in the eyes. "You never build the machine." Silence fell, heavy, final. Ethan's world shattered. Everything he worked for, everything he believed, gone. "If you never create it," the older Ethan continued, "you never go back, and the accident happens naturally, with fewer casualties." Ethan clenched his fists. "So people still die?" "Yes, but fewer." Tears rolled down Ethan's face. This wasn't a victory. It was a sacrifice. The older version smiled faintly. "I couldn't do it. Could you?" The timer on Ethan's watch blinked. 00:01. Time was running out. Ethan looked at the lab in the distance, at the machine, at everything he ever wanted. Then he looked back at himself, at the cost, and made his choice. The world flashed. Ethan was back in the lab, one final time. He walked slowly to the machine, ran his hand across it, memories flooding his mind. Then, he pulled the power. The machine shut down, forever. The next morning, the news reported a highway accident. 6 people dead. Tragic, but not catastrophic. Ethan sat in silence, knowing the truth. He could have saved more, but in trying, he almost destroyed everything. Sometimes, the greatest power is knowing when not to use it.